This video we're going to talk about another property of lines, and that is the slope. Now the slope of a line is really just measuring how steep the line is. So the slope is a measure of steepness of the line. Now, probably some of you have done some skiing or snowboarding before, and you would know that we have, let's see if I can make this work. On the ski hills, there's green runs, and they're usually shown by a green circle. And, oops. Then there's the blue runs, which are usually a blue square. And then there's the black diamond runs. And some mountains even have double and triple black diamond. But basically, as you know, these are the beginner runs, so they're pretty easy. These are the intermediate runs. And then these are the advanced or the expert runs. Now, the easy runs are easy. This is your board here. I'm no artist, but let's say, there we are. Okay. We would say that the steepness of the slope, or the slope of the ski run, is not very big. It's fairly flat. And then when you get into the intermediate runs, here's our board. Okay, so the runs would have a steeper slope. The intermediate runs and the advanced ones are steep. So really, that's all the ski hills are doing, is they're looking at all the runs on the mountain, and they're saying, well, this is not a very steep run, so we'll make it easy. This run here is quite steep. We'll make it intermediate, and this one is very steep. It's an expert run. So slope is a measure of how steep the line is. But how do we really measure slope, or how do we determine how steep the line is? Let's look at that. So by definition then, the slope of a line is equal to the vertical change, so how far up and down you have changed, or we call this the rise, divided by the horizontal change, which is how far over, or your horizontal distance. Sometimes we call that the run. So most people simply memorize slope as rise over run, or rise divided by run. So the ski hill, they might say, okay, well, horizontally, if you go 100 meters on this slope, then your rise, let's say, I'm making this up, let's say you drop 10 meters for every 100 meters that you go over. Whereas this run, if we went over the same 100 meters, maybe here you've dropped 30 meters. And here, maybe here for 100 meters, you've dropped 80 meters. Again, just making these numbers up. So we would say the slope of this run is rise. The rise was 10. That's the up-down part over 100. And of course, we could reduce that to 1 over 10. So the slope of this ski hill is 1 over 10. That means you're dropping 1 meter as you're skiing along, skiing down the slope. You'd be dropping 1 meter for every 10 meters that you went over. Here, the slope was 30 over 100, which is 3/10. So here, every time you ski along 10 meters, you'd be dropping 3 meters. And here the slope, again, rise over run, rise over run, vertical over horizontal, and reduced. Here you're dropping 8 meters for every 10 meters of horizontal distance that you would ski. So that's how we find slope. It's the vertical rise divided by the horizontal change, or the run. So slope is rise over run. And sometimes we can write it like this. Delta, this little symbol means change in. The change in your y values divided by your change in your x values. So this little symbol here is a Greek letter delta, and it means change in. The change in the y values, that'll give you your rise, and the change in your x values. And I'll show you that when we start looking at a graph, and then this delta y over delta x will make some more sense. So here I have a line drawn on this graph, and I've got a couple of points here. I've got one right here and one right here on my line. The line carries on forever. It's got the arrows there. But the line, I made this graph up so the line goes through this point and this point. So I'm going to put the coordinates of the point on here. This has an x value of 5 and a y value of 6. So the coordinates there are 5, 6. And down here I have an x value of 2 and a y value of 1. So if I'm asked to find the slope of this line, we know that slope is rise over run. So I need to know how far up did I go and how far over did I go. So my rise from this point here, if I was getting from this point here, we'll call this point A to point B. So moving from point A to point B, and I always move from left to right, so I'm going to start here at point A. To get to point B, how far up do I need to go? I would need to travel this far. That's 1, 2, 3, 4, 5 units. So I can say then that my rise is 5. Now I need to figure out how far over do I go. Well, I'd go 1, 2, 3 units over before I got to point B. So the slope is rise over run, and from point A to point B I need to go up 5 and right 3. So the slope is 5/3. Up 5, right 3. There is actually a quicker way of doing this, and this is where this change in y over the change in x comes in. So the change in y will always give you your rise, what happened to the y values. And the change in x being the horizontal axis here, will give you the change in your the change in your x values, which is your run. So another formula for finding slope would be to subtract the two y values. So the y value of the second point minus the y value of the first point divided by the x value of the second point minus the x value of the first point. So if we did that, the y value here, so I'm just going to call this now x1, y1, and this will be x2, y2. So this is my second point, this was my first point. So if I want to find the rise, I can just subtract the the y values. So 6 minus 1 is 5. 5 was my rise. So you could always graph it and count how far up do I need to go, how far right do I need to go. But if you have the 2 points and you want to find out the rise, just take the y value of the second point and subtract the y value of the first point. 6 minus 1, 5. And then do the same thing with the x's. So the second point x value was 5 minus the first x value was 2. Well, that's going to give you a change of 3. 3. So again, we get the slope of 5/3. So if you have the graph, well, it's fairly easy. You can count the squares. How far up do I go? And then how far to the right do I go? There's your slope. But if you have the 2 points, instead of having to graph them, it's sometimes easier to just go y minus y. In this case was 5 divided by x minus x, which is 3. And then we get the change in y divided by the change in x. Let's consider another example here. So I'm interested in finding the slope of this line. And I've got a point here, this is the point 5, 2, and a point here, this is the point -3, -2. -3, -2. And I want to simply know slope is rise over run. So I'm going to figure out how far up. Again, always starting from the first point on your left. How far up do I need to go? 1, 2, 3, 4. So my rise is 4, and my run is all the way over to this point. 1, 2, 3, 4, 5, 6, 7, 8. So 4/8, which I can reduce to 1/2. So this is telling me that there's a rise of 1 for every 2 units that I go over to the right. And you can see that's what's happening here. I go up 1 for every 2 units that I go over. Up 1 for every 2 units. Up 1 over 2. Up 1 over 2. That's the slope of this line. Or if I just wanted to use the points, I could also say that the slope is the change in the y values. So I'm going to subtract the 2 y values divided by the change in the x values. So y2, which is 2, minus, got to be careful here because the signs are negative, so 2 minus minus 2 divided by the second x value, which is 5, minus minus 3. And so 2 minus minus 2 is 4, 5 minus minus 3, that's like 5 plus 3, which is 8. 4/8 is 1/2. So there I found the slope of that line as well. Check out one more here. So here I have a line. Negative 1, 4 is one point, 5, 1 is another point, and we want to figure out the slope. So from this point to this point, as I move from left to right, this time I have to go down. So if you're going down, that's a drop of 1, 2, 3, so my rise would be negative 3, because I have to go down to get to this point. And since we're always moving from left to right, the run will always be positive. 1, 2, 3, 4, 5, 6. So now if I'm doing the slope here, the rise is minus 3 and the run is positive 6. So if when you're moving from your point on the left to the point on the right, you have to go down and then right, then our slope's going to end up being negative. And we can reduce this as well, so negative 1 over 2. So every time we go from left to right, we have to go down 1 over 2, down 1 over 2, down 1 over 2. And it still works fine with our points. If we do our y2 minus y1 over x2 minus x1, then this would be 1 minus 4 over 5 minus minus 1. And 1 minus 4 is negative 3, and 5 minus minus 1 is 5 plus 1, which is 6. We get that same slope, negative 1/2. So if when we move from left to right we go down, we're going to have a negative slope. If when we move from left to right we end up going up, then that will be a positive slope. And there's just a couple other unique cases that I'll show you here now. What if we had a horizontal line? What if our line's horizontal, like this one? So I've got a couple of points here, here and here. This would be the point 1, 4, and this would be the point 5, 4. We could still do this with our formula. So what is the rise as I go from this point to this point? Well, clearly the rise would be 0 because I'm not going up at all. And then how far over am I going? 1, 2, 3, 4. So the slope is 0 divided by 4, which of course is 0. So horizontal lines always have a slope of 0. And the slope of 0 simply means that the line is flat. It's a horizontal line. It works as well with the points. We could put it in here. So y2 minus y1 over x2 minus x1 would be 4 minus 4, which is 0, over 5 minus 1. So we get 0 over 4, which of course is 0. So we just need to remember that horizontal lines have a slope of 0. And let's look at what happens when the line is vertical. So here's a vertical line. X is 3, Y is 2. x is 3, y is 5. So when we're doing our slope formula, the rise from this point to this point is 3, and the run is 0. Now we have a problem here because we can't go 3 divided by 0. We can't divide by 0. So we say this slope is undefined. Or sometimes we say the slope is infinite. Undefined. But 3 divided by 0 we can't do. So this slope is an undefined slope. And we get the same thing here too. y2 minus y1 over x2 minus x1 is going to tell us that it's 3 divided by 0, which we cannot do. Undefined. So there's the case for the horizontal line and the case for the vertical line. Let's go back to that sort of skiing type example that we had. And we're going to look at why slope is, what the interpretation of the slope actually means. So I've made a little graph up here. This is a situation where we rode the chairlift to the top of the ski run and we got off at the top. And so on this axis I've plotted my height above the bottom of the ski run. And on this axis I've got time. So I get off the chairlift, and let's say you're a snowboarder, so you got to put your boots back on. So that takes you sort of half a minute here, 30 minutes, and then you start heading down the run. Now, the run's not always the same slope. So sometimes it's steep, sometimes it's not as steep, and sometimes you slow down, sometimes you pick up speed. So here we start losing some elevation pretty quickly, and then let's say we got a fairly flat part here, so we're not losing elevation so much. And then we get going again, so on. Maybe here we stopped and took a breather or waited for our friends to catch up. And then here we really started skiing down quick, got to a more flat spot, and then just gave her all we got here and really skied fast to the bottom. And then there we are at the bottom of the run. Let's say it took more or less 5 minutes to get down. So this might be a scenario where you ski or snowboard down from the top of the run to the bottom of the run. So what I've just put on here now is a blue line that represents sort of my average all the way down here to the bottom. So sometimes the slope wasn't as steep, other times the slope was steeper. But I've got an average line here, and I'm going to just put some coordinates on here. So this is the point 0, 400, and down here this is the point 5, 0. So if I figure out the slope of that line, then this will be rise over run. And we can count it, but I'm actually going to do the y2 minus y1 over x2 minus x1. So y2 is 0 minus y1, which is 400, divided by x2, which is 5, minus x1, which is 0. So I get negative 400 divided by 5, which when I reduce would be negative 80 over 1. Now, what does this mean? Well, slope has a lot of meaning in this application because the rise, this is my change in the y values, the rise is my height above bottom of the run, which is in meters. So these units here are going to be meters, and my run is the change in the x value, which is time in minutes. So what I can say from the slope is on average on that ski run that we went down to the bottom, I dropped, so minus 80 meters per minute. So the slope represents the average rate of change on that interval. So by interpretation, when we skied from the top or boarded from the top of the run down to the bottom of the run, the average drop was 80 meters per minute. Now, sometimes I wasn't dropping hardly at all, and other times on the run, my drop was much quicker. But on average, the slope would have been a drop of 80 meters per minute. So slope can represent the average rate of change on an interval. So let's just summarize those concepts of slope here now. So slope is a measure of how steep the line is. We can find the slope of a line by calculating the rise divided by the run, or the change in the y values divided by the change in the x values, which is really just y2 minus y1 over x2 minus x1. The slope, if we have a word problem, it could represent the average rate of change, just like the skier or the snowboarder going down the slope. If the line moves up as we move to the right, then we're going to talk about a positive slope. If the line moves down as we move to the right, then we have a negative slope. If the slope is, if the line is a horizontal line, then we have a slope of 0. And if the line is a vertical line, then our slope will be undefined. So that's slope, one of the important properties when we're talking about functions, and in particular when we're working with lines.